Alright, welcome everyone to T&TLog number 2. So this log I've been wanting to do for some time now because I feel it has been long overdue, and it is something we should have done at the very start of the course. And that is talking about the coder's mindset, or more specifically, how are you guys meant to approach the idea of coding in general, right? So here I have three things. I want you guys to stay away from brute force memorization. Um, you guys you guys are having like 5 or 6 other courses here at the same time, many of which do require brute force memorization or something or memorization to some nature of that, right? And we do not want for you to have to add another course to your memory logs, because it's very possible, it's in fact certain, that if you do add another, if you try to brute force memorize every single function and method and what have you in this course, your head will explode and we will be liable. And we don't want that, right? So, for our sakes, do not brute force memorize everything, right? My second point and my third point both go together, right? When you're coding, I want you to know what you code for, your general purpose, not really in life, but like when you're coding, you always want to code knowing that you're acting towards a finished product. Not in the philosophical sense, but like I want to um, find the maximum points in this database, just some value. That's my ultimate goal, at least in this question. How do I get there? That's the third thing. Once you know your goal, you should know the general steps on how to get there. Now that doesn't mean like you should memorize everything. It mainly means like know what code can do. And this is basically something that takes experience. When you're new to coding, you don't know the what coding can or can't do. It's just um, when you build up enough experience on coding, you'll get a general framework as to like, oh, um, what are the tools that I can use in coding more generally? Like, you'll be introduced to like arrays, lists, tables, different functions, and those will all give you a framework that informs you of zipper, that informs you of the capabilities and incapabilities of coding more than like um, you want to know what code can or can't do because that saves you a lot of time, right? It saves you from going down the wrong path altogether, right? So forth. During coding, what should you prioritize? Now I have four things you should prioritize. Now I created this acronym VEAL, VEAL, on the train, and like it's been sitting. It's not polished. It's very ad hoc. It's it. I wish I had a better one, but this is what we're gonna do for now. And I think it does a fairly good job of explaining what you should be going for, maybe to some extent. And I'll explain each one. So first off, viability. Now this is probably the simplest one. It's just asking, is your code doing what you intended it to do, or did you get did you accomplish your goal that you set out to do? And this goes back to actually creating a goal. If you don't code with the actual goal in mind, then you won't know whether your code is viable or not. It's just, here's my code. Is it the right thing? Well, no. So code with a goal in mind, and of course separate that goal into discrete steps. And that goes in tandem with the use of comments. And I'll give you an example here. So first off, I'll tell you what I want to do, right? So this pound sign and this green text is what I call a comment, right? So goal, I'll tell you what I want to do. I want to, hmm, what do I want to do? I'll do a simple one. I'll I will find the movie with the most votes. That's it, right? So, number one, what should I do? So this is my ultimate goal. What's my first step? I got to import the table. Not import the table. Well, I do need to import the libraries, which I already did, but I'll put it there. Import the libraries. Number two, import the table. Now this table is the imdb.csv. Number three is maybe isolate the columns. This isn't of some importance here because I think there's only like 4 or 5 columns in this table, but the farmers markets, for example, that has like 59 columns in it. You definitely want to make your life easier by just getting rid of the extraneous stuff, right? Okay, step 4. What do I want to do? Step 4. I want to sort the table by the votes. And now I will get the movie with the most votes. Sure. It's a bit redundant, but you get the idea. Okay. So these are my goals, these are my steps. What should I do? So first off, I should import the libraries, which I've already done here. Well, then I'll go to step 2. Step 2, import the table. So I'll do it in a separate thing. So import the table. How do I do that? Now this goes into something like a database. Now I remember I said you shouldn't brute force memorize everything. Now that doesn't mean you shouldn't memorize anything. You'll naturally memorize stuff just through experience. Like I already know the code I need to import the table off the top of my head, but some of you beginners might not have that. And that's fine. That's fine. You're only starting, man. Just chill. And then, so this is the purpose of a database. Database is extremely handy for you because it gives you all the tools you need to um you need to actually code well without the moral burden of memorizing stuff, right? So here is what I want, where I want to introduce the nature of a documentation. So here, say let's choose a random, let's choose, uh, let's choose matplotlib. So imagine I wanted to get all the functions and methods in matplotlib, right? So I would do matplotlib, and then I would do something called documentation. And here what pops up is this. Now, you'd want to look through this and find something called API reference. This is where all the functions and methods are located. So here it shows you, oh boy, that's wonderful. What do I need? Matplotlib, pyplot. So here, pyplot. And here it gives you all the functions and methods that are in matplotlib.pyplot. So here, axes. Interesting. I believe you'd have to you have to click on one of these, right? Axes. Oh, okay. Dot axes, and then they give you the arguments here. Okay, that's good. Now, benefit is it gives you a bunch of stuff. And in some of these, you might discover something that we do not focus on in the labs for some reason or another. And those might be beneficial to you. It might get the job done quicker. And that's always a good thing, right? However, the major disadvantage is that it is a deluge of information. Like, we will not be using semilog y and semilog x. We will not be using ax line, an infinitely long straight line. Goodness. We will not be using violin plot. Oh, I thought that was satirical. Oh, there is there actually is a thing called violin plot. But my point is, only about like 1% of the stuff you see here will actually be using. Just will be relevant in general to the labs. And sometimes, well, most of the time, you do not want to have to sift through hundreds and hundreds of these to get the stuff you actually need, right? Now, instead of a documentation, what I would actually recommend is building your own database. So, as an example, this is kind of too professional, I'd say, but in the summer program, I was I was frustrated by our inability to teach people how to code. And in my frustration, I created my own data set. Not data set, database of functions and methods in I think the first three labs. So 1, 2, and 3. And here are the stuff from lab 3. I put exercises because below them there is a bunch of stuff that's not really relevant. What I want to focus on is the database. So here in a database, you would be, oh, my battery. You would be listing all the functions and methods you come across in your labs. So here, um, I just documented this by going through lab 3 itself and just documenting any and all functions and methods that came my way within the lab. So I saw, oh, dot show, I'll just put it here as another row. You don't have to format it this nicely, I just thought I had to. Um, so whenever you're confused, whenever you got something you gotta search up, you forgot something, that's fine. Just go back here, search for it right here in your own database. I probably won't share mine with you. Okay, for example, we're on step 2 right now. We gotta import the table. How do we do that? We go here. Oh, creating new table from CSV file. Oh, it's new table equals table.read underscore table file name. Cool. Now I remember it. So now we just go to, let's do a variable imdb equals table.read underscore table. And then file name is imdb.csv. And let's just check if we did that. Table.read underscore table. Everything's lowercase except for that t. That's fine. And theory that should work. Wow, it did. All thanks to our database. Cool. Um, Now we got step 2 done. We gotta do step 3. What are the columns we gotta isolate? We just gotta find the movie with the most votes. So we need the votes and the title because we want the movie title itself. So how do we not filter? How do we get select? How do we only get specific columns of a table? Hmm, I don't know. Let's go back to our database. Let's see. I do recommend sorting by, not sorting, but listing a function's purpose and its structure in this case. So creating a new table, reading the full table, selecting row, selecting column. Oh, this one, selecting a column in table format. I should have done selecting columns in table format, but here we are. Dot select. So here, I'm gonna call this IMDb sure filter equals IMDb where no select what are the headers? So votes and title. So votes, sorry, and title. And I just gotta call it. Boom! We got a filter table with just the votes and just the title. Wasn't so bad, was it? Okay, we've done step 3. Now we gotta do step 4. Sort the table by votes. Now we need the most votes. So here we gotta do, oh no, I just had a brain fart. I don't know what the code is to sort a table. Let's go back to our database. Let's see. Reading table, restricting table, selecting row, oh shit, here we go. Sorting the rows. And what does it look like? Existing table dot sort, column header, descending equals true or false. And then I just added descending is automatically set to false, put it to true if you want highest values first. Well, we want the most votes. So we're gonna do descending equals true. Wasn't so hard, was it? Okay. Now we gotta do IMDb. I'm gonna call this votes sorted. Sure. Equals IMDb underscore filtered dot sort. What do I need? Let's look back at this. Column header and then descending equals in this case true. Oh no. Okay. Why did I say oh no? Um, so we want to sort by votes. And we want descending equals true. And we just call that. And look at that. We got a sorted table with votes determining how it's sorted. So the first column is the one with the most votes. And now we just need our last step. Okay, get the movie with the most votes. I'll put that in the variable movie with most votes. And how do we do that? How do we do that? Oh, this might be a bit broad. No worries. Adaptation is always fine. So that was step 5. We might need some sub-steps. So 5 was get the movie with the most votes. That seemed a bit too complex for us. So how do we do that? Ooh, I don't know. Oh, actually I do know. But how about this? First, we get the title column as an array. And then we, what should we do? We would get the first term, right? Okay, now what? Movie with the most votes? Movie with the most votes. We gotta do 5A. Let's hold off on this for now. Okay, 5A. Get the title column as an array. My god, I don't know what that is. Let's go back to our database. Oh no, selecting column in array format. This looks like what we need. Okay, what does it look like? Existing table.column, this or this. Okay, that seems easy enough. We will do, um, about title column equals. What do we do? do we do? What is the meaning of life? Oh my, I have a brain fart now. Shame on you. Um, what is it? Oh yes, title. What's our title? Not title. What is our table name? So IMDb vote sorted. Dot column, and then title. Now let's just call that again. See if it works. Cool. That's a lot of titles. Okay. Now I can just edit this again, get rid of that call function. But now we want to do 5b, get the first term. Now I'm going to do dot index, right? So this is movie with the most votes equals title underscore column dot index 0. That's the first term. And I'll just call that again. No! No object index, no attribute inject. I was just going off my memory there, but as you can see, memories can be faulty, right? So, what do we do? I remember I have exercises for lab 2. This is why we need databases for everything. How to make a composition. Getting the index of an element. No, that's not what you need. Getting an element from its index. Existing array index of element. Oh, it was that simple. Okay. Then I will just do dot column, not dot column, brackets 0. And look what I get. It worked. And I have achieved my goal of finding the movie with the most votes. Right? Now this is a pedantic, not pedantic, but like kind of satirical example. It gets too in depth. You would not need, maybe you do need, especially if you're a beginner. But um this might be a bit much. You don't have to specify every single detail. Just do it so long as you have do it so that you have a good structure. If you could group 1 and 2 into just import libraries and table into one single step, that's fine. Like isolate the columns. You might not need isolating the columns just from how little columns there are in this table. That's fine. Like there isn't a set series of steps that works for everyone. Everyone has different capabilities, different levels, all sorts of that. Just use these steps to put structure in your code, right? That's what you got to do. Okay, I demonstrated that. I used comments in abundance. I coded line by line. That is something that is a lot more in the vein of like nested functions, right? So, as a second example, say so. As a second example, say I wanted to find the average votes for a movie. Now, what are my steps? We already got the table. I already even got um, oh, never mind. Well, I need to extract the votes column, right? And I need to then find the average. Now, instead of like defining every odd thing, I defined IMDb, I defined the filter table, I defined the sorted filter table, I defined this, I defined that. You can just do nesting functions, which is great because it is faster. The kernel has to do less things. However, the code does suffer in legibility, which is something I'll get to. But here, just for the sake of fun, we'll do step one. Extract the votes column, right? So looking back, that was dot column. Oh, I was not specific enough. As an array. So IMDb votes, no, not votes, maybe filtered. Yeah, IMDb filtered, yes. Dot column, and that was votes. Now we can just run it right now. Oh, it gave us all the votes. Good. Now I'm not going to define it as another variable. I'm going to nest it in another variable. And this will be step two, find the average. This will be mp.average. And look at that. I got this. This is the average votes for a movie. Cool. Great. So that is an example of where you use steps, but you don't define everything. You would do piece by piece. So we did this inside piece first, and then we did the outside piece first. Have a database handy. We already did that. Priority high. So generally, it is important for your code to be doing what you want it to do, right? Now, yeah, I'll leave it at that. But the second one is efficiency. Is your code taking the most direct route to your goal? And my big summary of question is, what good is your code if it takes forever? Like, it's great that your code works, but you don't want to be sitting there for 10 minutes waiting for it to do it. You would rather do it in like 1 minute or a few seconds, you know? Um, so the main idea is that kernel progresses like a human does. And the main thing is a for in loop. Now I'm gonna build something here. I might be breaking my own rules, but like I wanna prioritize speed here. I'm gonna um how about this? I'm gonna do something like this. For I in now now you don't need to know loops to understand this. I guess you do, but I'll tell you that this line just repeats whatever is indented following it 1,000 times. Now, say I wanted to do this is an essential part of permutation testing, which is the subject of the T&TLog 1. But what if I wanted to sample some rows from the table? So I'll just put everything here. You might not understand this now, but like I'll get like to the main point soon. Table dot not table. What table? Um, IMDb dot filtered, not dot filtered, underscore filtered. Sample number of rows. Oh, I didn't define that. Now this is my big error. I'm gonna put this within the column, so oh, this might not be a good idea. I'll look at this is a it's a very bad idea. What if we wanted to sample half the table each time? Okay. How many rows is that? Well, we need num rows dot. So the IMDb filtered dot num rows, and that we'll define as rows. So, oh, divided by 2. So we're getting half the rows each time, and then we might just Um, huh. IMDb filtered sample rows. All right. So the second part is about efficiency. Is your code taking the most direct route to your goal? So I'll be honest, this is not really important if you're just learning code. If you're just learning code, just getting to your intended goal, that's good enough. Um, Problem is in the especially grueling statistical tests, a lot of stuff is gonna happen, and like that stuff might take a long time. And like there's the age-old question of like what good's your code if it takes forever? Like it's great that your code is doing what you want it to. Do you really have to wait 10 minutes for it? That's a hell of a long time, right? And if your internet dips at any time along that 10 minutes, you got to start over. That's not optimal. So once you get advanced enough into coding, it's when you'll typically look into issues with speed, um, and like trying to prioritize having a faster time. And I'll be honest, Python is not built for speed. So know that there is limits as to how quick you can make code run. But still there's mainly two things that slow Python down. So for in loops, um for in loops are very troublesome in that they make the kernel repeat everything in its loop a certain number of times. So if you make the kernel do something like 10,000 times, that kernel will struggle. It will take like 10 minutes. That is just the truth of it, you know? Now, in order to minimize it, um, you have to be absolutely certain that what is in the loop is actually what is in the loop. Like what is in the loop is actually what's meant to be in the loop, and what's outside is actually meant to be outside. I won't give any examples because that would take forever, but that is the basic gist of that. Now, assignment operations, um, they are very bulky in terms of speed. So you might not comprehend it because it goes so fast, but um, assigning something to a variable does take does take relatively long time, especially compared to like arithmetic, um, some simple stuff. You would rather be nesting functions like this in or instead of defining everything, because remember, defining takes some time, and if you're repeating something 10,000 times and you're defining something in each of those times, that those itty bitty times add up quickly, and you get like differences within the minutes. Like if you were to nest functions instead of defining them, you could save like yourself 5 minutes if you're repeating something for like a seriously large amount of iterations, you know? So generally, I'd say efficiency is priority of medium. Like if you're just learning stuff, it's not on your shouldn't really be at your top priority. But if you're like advanced, you've got your code, but like there's some problems with speed or getting impatient, you might want to focus on it, right? Now there's adaptability, right? Can you easily generalize your code to work for other scenarios? Now, this is something I thought up on the fly. I'm kind of on the fence about actually including it just because it might not be relevant to this course, kind of, maybe. But one of code's biggest advantages, besides being able to handle seriously large amounts of data, is that you can tweak it just a bit and it can work for like some other purpose, not some other purpose, but like some other thing, right? That is similar. Now, to show you what I mean, I could switch this um for farmers markets, right? And I could change this to farmers markets and then farmers markets. And wow, it just gave us the farmers markets table. I've just adapted my code to do something else. And same thing here, filtered, uh, farmers filtered, sure. And then I can select market name and the, let's do the X. Market name. Oh, IMDb. I forgot to do that. Farmers markets. And now I can just do this. Filter. Oh, it's here. Yes. Good. And then we can continue going down and eventually find, I don't know, the market with the largest X, the market with the smallest X, that sort of thing. But you see how easy it was for me to adapt my code to something else, right? Um, Now I'll admit that if you're in the labs and you're doing the problems, you can do away with just not thinking about adaptability. That's why I wrote priority low, because I admit that sometimes you're doing code for one specific purpose and not might not be generalizing it to everything, but it's generally a good idea to think about like, hmm, how could I branch out from this specific example to everything else? Right? That I feel that there's some use in that, especially um, if you want to get some more practice with coding beyond the specific examples you find in each lab. Okay, lastly is legibility, and that I feel is the most important. Can others read and understand your code? Now, this is very, very important for debugging because you can't really debug what you don't understand. And it makes your life so much easier later on because you can understand your own code. And how should you do that? Oh, I have two tips. Use comments at length because there you have free will as to how you can explain your code. And you can personalize. Oh, you should personalize with caution. So I'm being very specific in my variable names. Farmers filtered, that's the filtered version of the farmers markets table. IMDb votes sorted. It was the IMDb table with that was sorted by the votes column. Now you don't have to structure it exactly like that, but note that any vague um, any vague variable names will decrease your legibility, right? If I showed a data science, like if I showed anyone, just stop someone down the street and showed them this code, they would know that this variable stores the um they would know they would know they would at least have a general idea of what's inside this variable just from the name itself. In comparison, say I said like soup equals soup has no relation to this. And so this is a bad name for it. Very bad. Now this oh now this is a better name. It's an array of numbers. Oh, it's not an array of numbers. It's a list of numbers. So now it's a list of numbers and it is a list of numbers. So now this is more legible, right? So here it's very high because others can understand your code. You will be able to understand others' code if they have legible code, and you can understand your code for when you're coming back to it after a break or something like that. And as a bonus, this is going to be the last thing I talk about. It's all about debugging. So say you're like having trouble on this one thing. You've done something wrong with your code. It's giving you all sorts of this weird stuff. You don't know what's wrong, right? First point, you could learn from this in that if you're unsure of what's wrong, there might have been a problem in your legibility, especially. Now that means use more comments, make more fitting variable names. Um, but beyond that, how should you do? Look at error messages. Sometimes error messages are vague, but sometimes they can be very helpful in telling you what's wrong because they even pinpoint the exact line that the error occurs. Put yourself in the shoes of a variable. This is especially for the conditional like if then and the for in iterative loops. You want to be following a variable, seeing what happens to it in the conditional or in the loop, and that will often be a source of like, oh, I found this like this variable. I used the wrong type of variable for this. This wasn't being put in as the input; it was being something else. That sort of thing. This can be immensely helpful about figuring out where exactly something went wrong. Then test parts of the code out in separate cells. Um, Again, this is for very dense code that I'm not going to show here, but like, especially nested stuff. Like here, maybe this part had a this part was like 3 or 4 nested functions on one, and there was something wrong with it, right? And you're and okay. So what you could do is you could test out each part. So I'm going maybe I want to see, is the table doing well? Oh, the table's doing well. Okay, good. I can add a column to it. Huh? Okay, the column's doing well. So I can test out each part of this nested code just to see where it is in a separate cell. I can test out each part in a separate cell in order to find where exactly the error is, right? Okay, improve the legibility yourself, untangle nested functions. Yeah, okay. That could be something like turning nested functions into defined stuff. Um, that would go in tandem with doing it in separate cells. Of course, doing this would improve your speed, but you know, there is some benefit to separating nested functions and methods in order to find where exactly something went wrong. Be aware of the purpose and the steps, of course. If someone's been legible, um, their purpose should be clear, as well as any steps they did to get there. So I'm being really explicit in telling what I'm doing. This is like the best case scenario, honestly, I think. But, making it clear what you're trying to do through code, that will definitely help you find where you went wrong. And use Jupyter's color coding to help you. Okay, so just last one. Um, Jupyter is very helpful in that it has colors that regular Python does not use. Um, and those can help you deduce syntax errors. So syntax, something like this, syntax error here. And it's like, it basically means some grammar rule, some organizational rule was just not followed. So here, any unpaired parentheses must be matched with one of the opposite direction, and that gave you no error. So here you see when it's paired, you've got green, when it's unpaired, you got red, right? Now this can be very um, eye-opening for when you've got a bunch of nested functions. Imagine each of these has a function or method. You've got like tens of thousands of nested functions. It's tiring. and you're like putting in parentheses, and you like you just forgot one at the end. And like, oh wow, there's a syntax error. Let's see. Oh no, this one was red. That means that this one was not paired, so we just gotta add an extra one. That's fine. And same thing if we add in too many on the right side. Oh, this one's red. There was nothing here to link it with, and it'll give us syntax error. And that's just the end of my PowerPoint. Um, yep, just some basic stuff for you to generally structure your learning process around. Feel free to comment if you have any questions, and I'll see you in the next T&T log. Alright.